All right, today we're diving into a really fascinating paper by an independent researcher named J. Alfred. And he asked the question that sounds like it's straight out of science fiction. What if we're not alone on this planet? Not because of aliens from space, but because there's an entire invisible biosphere, a whole other world existing right alongside us, completely unseen.
So let's just start with a number. 20%. Let that sink in for a second. According to a 2023 analysis that J. Alfred cites in his work from the IceCube and Super-K neutrino detectors, up to 20% of our own planet's mass could be made of dark matter. We're not talking about out in the galaxy. We're talking about right here, under our feet. And that number, that 20%, is really the jumping off point for the first big piece of J. Alfred's whole argument. He's basically saying that for decades, we've probably been seriously underestimating just how much dark matter is gravitationally stuck to our own planet. And this idea, well, it hasn't just come out of nowhere. It's like there's been a trail of breadcrumbs building up over the years. You go back to 2009, you have physicist Stephen Adler looking at these weird speed changes in space probes flying past Earth. His theory? Maybe they're passing through a dark matter halo. Then, jump to 2014. Professor Ben Harris uses GPS data, yep, the same stuff in your phone, to argue that the Earth is actually heavier than our official estimates. And that brings us right back to that 2023 neutrino data, which dropped that bombshell figure of up to 21%.
So all the evidence seems to be pointing to some kind of missing mass. There's something there that we can't see. But this is where it gets really, really interesting. What if that something isn't just a boring, passive cloud of invisible dust? This is the exact question that the researcher J. Alfred uses to launch his entire theory.
And this brings us right to Alfred's core idea. He theorizes that this hidden matter isn't a gas, it's not a solid, it's something else entirely. Something he describes as a kind of ghost-like plasma. Unseen, unfelt, but all around us.
The term he uses for this is self-interacting dark plasma. So what does that mean? Well, the key idea is that these dark matter particles aren't complete loners. He suggests they have their own version of an electric charge, a very, very weak dark electric charge. And that allows them to interact with each other using a kind of dark electromagnetism, which lets them form a stable, organized plasma.
Now, this is a really crucial difference. The plasma we all know, like in the sun or a bolt of lightning, is super chaotic and unstable because of its strong electric charge. But Alfred's dark plasma, with that much weaker charge, would be inherently more stable. And here's the secret sauce. That stability means positive and negative dark charges could actually separate from each other and stay separated, which is something that's pretty much impossible for ordinary plasma on a large scale.
So if you have a stable, self-interacting dark plasma just hanging around, what does it do? According to Alfred, it doesn't just float around in a random cloud, no. It gets organized. It builds something on a planetary scale. And this direct quote from J. Alfred's paper really lays out the mind-bending concept he's proposing. He says that this dark plasma forms huge dark plasmaspheres that actually interpenetrate the ordinary matter, Earth. And he calls these structures dark Earths. So, yeah, he's suggesting our planet is sitting inside one, or maybe even more, of these vast, invisible plasmaspheres. And to help you wrap your head around the sheer scale he's talking about, Alfred gives us a great analogy. Think about Jupiter. You've got that small, rocky core deep inside, but it's surrounded by that absolutely immense gaseous envelope. He suggests the relationship between our little rocky Earth and the smallest of these dark Earths is just like that. Our planet is the tiny core, sitting inside a colossal plasma body so vast you could fit over 1,000 Earths inside it. It's staggering to even think about. Alfred even sketches out a possible structure for this dark Earth. He theorizes that the heavy, positively charged dark particles would sink down to where our planet's core is. Then, way out, we're talking 70,000 kilometers out, you'd have a shell of light, negatively charged particles. And right here, in between, where we are, is a region dominated by neutral dark particles. The whole setup would basically act like a giant natural battery or a capacitor. Okay, so let's recap. We've got a hidden mass, a stable plasma structure, and a built-in energy source from that charge separation. With all those ingredients on the table, J. Alfred makes one final, incredibly provocative leap. Now, as wild as this sounds, he's not totally alone in thinking along these lines. Alfred actually cites theoretical physicist Lisa Randall, who once speculated that this kind of self-interacting dark matter could, and this is her phrase, in the most extravagant leap of possibility, allow for dark life. Alfred's paper is essentially trying to build a plausible framework for how that extravagant possibility could be real.
So, what are the necessary conditions for life in this scenario? Well, Alfred lays out three key things. First, stability. This dark plasma is calm, not chaotic and destructive like the plasma we know. Second, you have all those neutral particles acting as a kind of buffer, creating a calm medium for things to form. And third, and this is the big one, you have a sustained energy gradient from that charge separation, which is a fundamental requirement for pretty much any biological process. So you put it all together, and you get to the absolute culmination of Alfred's theory. These dark Earths aren't just planets. He's suggesting they're biospheres, vast, invisible ecosystems that have had billions of years to evolve complex and, yes, potentially intelligent life forms made of dark plasma. Right, so that's a mind-blowing idea, but you've got to ask the big question. If this is true, how could we possibly know? Is there any way to actually test an idea this far out there? Well, Alfred thinks there is. He proposes a completely new search paradigm. We all know about SETI, the search for extraterrestrial intelligence, pointing telescopes at the stars. Alfred suggests we start SITI, the search for interterrestrial intelligence. Instead of looking out there, he argues we should be developing experiments to look for signs of non-human intelligence right here, coexisting with us in a different state of matter. And he does suggest a few potential methods. Things like monitoring so-called ley lines or ancient sacred sites for weird energy signatures, analyzing our existing geophysical data for ghost signals we can't otherwise explain, re-examining those spacecraft speed anomalies, maybe even listening for unnatural signals that could only be generated by dark matter interacting with normal matter, or mapping persistent streams of ionized air that could be the wake left behind by this hidden world. Ultimately, J. Alfred's paper pushes the absolute boundaries of scientific thought, and it leaves us with this one profound question. It forces us to consider that the greatest discovery in human history might not be found in the distant stars, but hidden in plain sight, in an invisible world that has been here all along. Are we sharing our planet without even knowing it?